Hi, welcome to the 6502 show. Today we're going to take a look at one of my favorite subjects, Tiny Pilot, but this time it's a version for the Commodore 16 and the Plus 4. You know, I recently, this winter, came into a Commodore 16. This bad boy right here. So, I've never had one before, and I thought, I need to check this thing out, because it would certainly have been a major step up for me from the VIC-20 back in the mid-'80s. But, you know, they came and went here in the United States so fast, it was really kind of hard to find them. They were here, they were gone. That was it. So far, I've really enjoyed the machine. Its BASIC is so much better. BASIC 3.5, oh, night and day. And quite frankly, I don't even miss the capability of having sprites on the machine, you know, able to program those like the Commodore 64, because I never had a Commodore 64. I went from my VIC-20 to a Commodore 128 that I used almost solely for writing papers in college when I was an undergrad. And before I even graduated, I had moved on to a Mac Plus. And then I got involved with other stuff, and computing was forgotten for decades. Well, anyway, with this Commodore 16, the only thing I'm really kind of losing is one voice in the sound registers. It's only got two voices rather than three in the VIC-20. And of course, it doesn't really hold a candle to the SID chip in a Commodore 64, but you can still do a lot of good sound effects and make a little music with it, as we saw in an earlier video. There was a really good version of Pilot for the Commodore 64 that came out in 1982. But there never was a version of Pilot that was for the Plus 4 or the C16. I felt I needed to remedy that situation. So, after having spent a lot of time with Tiny Pilot for the 6502 and porting that to 6800 code as well, I thought, this shouldn't be too tough. And sure enough, it wasn't. The main things I needed to do was have keyboard input for the Commodore 16, and then screen output. And then I wanted to add some bells and whistles, a little bit of sound, a little bit of color, nothing too crazy, but something just to make the program a little more fun to use. I've gone into Tiny Pilot in depth in a couple of other videos, and there'll be links to those in the description below. But let's go take a look at Commodore 16 Tiny Pilot and some of the differences and some of the things that it can do. Right here we have the editor commands of the very simple-minded editor in Tiny Pilot. The screen editor is on in Commodore 16 Tiny Pilot, so don't use the cursor keys. It's just going to mess you up. It's going to mess up the screen. There's no need to use it at all. And, you know, as everyone knows who has a C16, the cursor keys are in the worst possible place for them to be, so it's easy enough to ignore them. The main things you're going to do with this thing is you're going to use the @ sign to start execution of a program. You might do a little bit of listing by tapping the pound key, clearing RAM before programming, or loading something in's handy. But the main one, other than the @ symbol, is going to be the back arrow. This exits you to the C16 monitor. This is where we're going to load and save programs. I'll demo that a little bit later on. For those of you who are thinking about writing dialogue-driven scripts, either for educational purpose or for maybe an adventure game or a choose-your-own-adventure style of game, I have a second version of Tiny Pilot just for you. It is called Tiny Pilot with Copilot, and a guy named Robert Schultz wrote this in 1980 to add into Tiny Pilot. There's all kinds of information about this in the documentation package that comes with the Pilot. And basically what this allows you to do is make a match anywhere within a given response in the answer string. So somebody says, what primary color do you like? they might say bluish green, and you're not looking for that. You're looking for a primary color. So if it matches any of those things anywhere in the response, you won't get a primary color. The answer, someone might answer, I like green. Well, green is in the response, and so you'll get a yes match. In the standard version of Tiny Pilot, it's only going to match the first thing it sees. So if you type in I like green, you won't get a match because I does not match anything in green. So while the standard version is much preferred for doing things with math, because that way I can test variables with it and test it against ASCII, the ASCII representation of a variable. That would not do with this Copilot thing. It messes things up grandly. However, if you're looking to have a little more flexibility in matching responses from a user, then this is the thing you need. It's included in the package, as mentioned, but 90-odd% of the time you're going to want to use standard Tiny Pilot. The T statement gets quite a bit of an overhaul. Here we can print out variables, and we can print out information, whatever text string you want, but we can also print out different colors. And we could clear the screen, we could turn reverse on or off, and the ability to turn on and off the reverse mode means that I have full access to all the Petsky graphics. And we'll take a look at that here in a demo coming up. You can ignore that pipe next to the little ampersand end. That's actually the cursor that I left sitting up there when I did the screen capture. Sorry. But ampersand is the marker to do a text attribute change. The closed bracket is a marker inside of a text string to generate a sound. And you got 4 sounds available: bell, blip, bong, buzz. And they're simply embedded into your typed out string. So looking at the example at the very bottom, we've got a closed bracket 1. So we will ring the bell, and then it will type out, you have changed the color to red. That's the ampersand 3. The $X will print out the contents of the variable X in ASCII. And then the word marbles left, a comma. We're going to change the color to cyan. And then we will print out a question mark and a period and change the color to yellow before we go back on the second line and simply type by. Originally, Tiny Pilot's variables and flags and work areas were all contained in zero page, which was pretty easy to do because the Kim one and the Sim one only used 17 to 20 locations in zero page, and the 6800, say SWATbug and McBug, don't use zero page at all. Very convenient place to put things because you've got direct addressing right there, and it's a lot faster. Not so on the Commodore 16 and the Plus 4. Zero page is pretty well locked up. I mean, not nearly so bad as the VIC-20 or the Commodore 64, where, if you've got 6 bytes, you're living high on the hog. But we were going to have to move some stuff here for C16 Tiny Pilot. And no place better to start than at the top. Or the bottom in this case. The bottom of user RAM is where we're going to set up shop. It'll run a little slower, but, what are you going to do? It's plenty fast enough. Some things did have to be preserved on zero page because of indirect Y addressing. That happened there, and it happens right here. For the clear memory command, we set up an entry point here into our monitor for the Commodore 16 and Plus 4. We note a TED timer, which we're going to use in part of the startup routine. And the program itself will start here at 1100. While not included in the original Tiny Pilot from 1979, we do have here a welcome banner, and I've tacked on to that seeding of the random number generator. It's not particularly a great routine. This helps it out immeasurably. We set our colors here for background and border, And then we print out the header here. And then we go and seed the pseudo random number generator. And because we're dealing with decimal numbers, binary coded decimal, we need to strip off the high bits on these nibbles so that we make sure that we're getting at least something that Tiny Pilot can deal with that's under 99. You'll also notice right here that I've got a series of bytes that correspond to the text colors that we're going to be able to use. But in some cases, it's going to be able to do a few other things. For example, this 92 will, or 92, since it's hex, what this will do is turn reverse off. This turns it on. This is yellow, right there. That is white. And that is red. You can figure out how the rest will go. It's the primary colors that you can get on the C16 when you hold down the control key and tap one of the numbers. It's labeled right there. You can't miss it. Why is there no black? Well, because the screen is black. The background is black, and we're not changing that at all. Now let's take a look at the T statement, type, and this is where it comes to print out a line. So it's going to interpret the line that it has after the T colon. And what we're looking for here is we're checking the flag here to see if we're in the editor. If so, we don't need to look for any special character. This is print a variable. But also now, it's print a text change marker or a sound marker that we can look for. So our first comparison will be for that closed bracket. Is it the special sound marker? Well, if it isn't, we'll go check for color. If it is, we'll go and jump down and do some sound processing. Here is where we determine if it's color. If yes, go change color. And then it continues on with the original check for a variable marker. Well, let's say that we do have the ampersand. And so it will jump down here to this code called do color. And all we're going to do is we're going to bump our index to the next character, and we'll get the color code there. And that code, well, it says 1 to 8, but it can be from 0 to 9 because we've added, I added the reverse, I guess, after I wrote the comments here. You can turn reverse on and off, and code number 1 will clear the screen because there's no point in setting your text color to black if the screen is always black. So I decided clearing the screen might be a good idea. Otherwise, it's just the same colors you would expect. So we're going to look for numbers. We need something from 0 to 9. And we'll compare it there. And if it's not a number, we'll output it. Then we'll check the upper limit if it's past the numbers. So if it went past 3.9 and is now 3A, that's no good either. And then we'll subtract 3.0 from that to get a number from 0 to 9. Put it in X, and we'll check that colors index that we saw earlier. Pick the right Petsky code, and we'll output it right there. Sound was something different, though. You can't print a sound. And I thought first, well, how about we do another statement that is just for sounds, and it will pass a bunch of parameters to the TED chip, generate the sound for, frequency, duration, etc. And that was going to take variables, probably. I mean, I could have done it some other way, but suddenly now it's getting more complicated, the code's getting bigger, and I thought, well, what else could I do? Well, at the same time that I was working on Tiny Pilot, I was working on translating a game back from 1983. It was an adventure game by the Doppelganger, and it was his Polita Moors, originally written in Auric Basic, Auric 1. Well, the Auric Basic is interesting in that it has some keywords that are sounds, embedded sounds built into the basic language, like zap and explode and ping. So I thought, that's perfect for Tiny Pilot. I'll add 4 little sounds, and they're just all self-contained. And then that way, it won't be too complicated. And really, how many sounds do you need in Tiny Pilot? Well, I took that and decided to have bell, blip, wee, fun with cursors, bong, and buzz. And if it's not one of those four, go print whatever it was, because it ain't a sound. No error checking here other than, is it one of these? And then it could print anything. And all I did was build these sounds. I'm actually particularly pleased with the bell sound. It sounds good. We will hear it later on a demo. But here's the code for blip and a bong and the buzz right there. And it's all hard-coded right in. We're not touching, we're not passing parameters or anything. There's just, this is what it's going to sound like. And if you want to change it, you're going to have to change the source code. But that's up to you. Feel free, man. You bet it can, Johnny. Let's first load in Tiny Pilot, and then we will load a baseball playing game into Tiny Pilot and give it a whirl. Okay, that's what's on the directory there. Better do it again. I didn't see exactly. Tiny Pilot -C16. Okay. Boop. You type the wrong thing. Now we're good to go. And we're loading. And we're ready. And start Tiny Pilot. Sys 4352. Boomsies. And we're up. Okay, again, to load, we're going to use the back arrow command to go back to the monitor, so to speak. And that's what I shall do right now. And I'm in the monitor. Now on that disk were a bunch of games and demos and other such things. And I think you're seeing the cat. Hello, cat. Such is life. Yes. Yes, you're helping. Okay, enough of cat. Let's just work around the cat and load a program. So the first thing we want to do is we're in the monitor, and all you have to do is load and give it the name. Aruba BB Dice. Aruba Baseball Dice, (8), and everything is position dependent, so you don't have to put (1). It'll still load it where it's supposed to go, which in this case is hex 1700. Oh, you really want to play some baseball, don't you? All right. All right, we're finished loading. And I don't know if I'm going to get this. I may need to take a break. Stand by. "15 minutes later. And we're back. Okay, let's take a look at Aruba Baseball Dice by going back to the interpreter and executing. Hey, there we are. Aruba Baseball Dice with a graphic of the flag of Aruba. Apparently a very low-flying airplane coming right over my house. And we're asked to switch to lowercase and then press return to start. Well, easy enough to do on the 16. And it's just a baseball game, just like the baseball games that you might have played when you were a kid, with just a pair of dice and some simple rules about what the dice results will give you. And it takes into account some errors and double plays and sacrifices advancing on a deep fly out, all the things that happen in real baseball. So we enter the game. Let's say it's the Tigers versus the Blue Jays. And a random number to seed the generator, even though it is seeded by the timer on this. That's kind of a holdover from the 6800 version of Tiny Pilot. Not really needed in this version. The Tigers are up to bat. No outs. Press return to roll. We roll. They get a 3 and a 1. Lead off single. Batter on first. So you would move your little tokens around your little paper diagram of a diamond, and you just keep playing the game. The next thing I want to show you is the classic game conversational program ELIZA, written I think in the very early 70s at MIT. Joe, can't think of his name. It's going to pop up here in just a second. Anyway, this is a version that was originally for Atari Pilot that I translated into Tiny. My dad. This could go on and on. Clearly, this is something I need to explore more in depth. Lastly, we'll take a look at a dice game called Wipeout. This is a classic from 1979 that appeared in Cursor tape magazine for the Commodore PET. And this shows that Tiny Pilot has sound, has graphics, changes colors, does all the things that you would expect a good program to do. All right, pop back into the interpreter, and let's run it. From Cursor 11, apparently. Zero out all 10 numbers on the board using the total of 2 dice. All right, if we get doubles, we get extra rolls. 6. I will remove 1 number, and it will be the number 6. Ooh, I got a 10. That's going to be very helpful. We'll just take off that 10. Got another 10. This time, I think I'm going to take off 4, 3, 2, 1. Then that's not going to leave me much to play with. I think I'm going to go 7 and 3. So I'm going to take off 2, take off the 7, take off the 3. And we just keep playing right along. We take off the 5 or 1 and 4 here. And it's pretty tough to win. But this is just, again, a little demo to show color, animation, sound, the whole shooting match. That's Tiny Pilot. But before we leave it, let's take a quick look at what the graphic dice look like in actual code. Here we can see the top of the Wipeout game for Tiny Pilot. And what we have here is the first line is jump to label G so that we don't print this stuff out at first. But this is a subroutine U. And we're going to check variable L, which is the result of a dice throw, a random 1 to 6. And we're going to match it. Is it 2? If it is 2, jump to subroutine V. If it's 3, W, X, Y, Z, etc. for 4, 5, and 6. And if it's none of those, it must be 1. So we just fall through and go right here. All right. What we have is we're printing a couple of spaces, turning on reverse, printing a Commodore K, so that's a Petsky graphic, and then we've got a couple of spaces here, which will print out solid blocks. We'll turn off the reverse, and then we will print another Commodore K. This goes on to make the dice. We're just using the period for our dot. So here's 2, and you can see 3 being made here. Well, right there anyway. Etc., etc. Pretty simple stuff. Saving something in Tiny Pilot works just about as simply as loading, but there are a few extra little steps. So we cleared out memory with the zap command from the editor, and let's write a tiny little program. And stop. You have to end every Tiny Pilot program or script with S:"stop. Otherwise the interpreter crashes. Just what it does. But you can put in an end command. Alright, so let's execute it. Watch it run. Yep, it does what it's supposed to do. Now we want to save that. What we want to do is we're going to search from the top of user memory, which is 1700 hex, to that final S:, and there'll be a trailing 0, which is the marker for end of line. So let's pop over to the monitor, and let's take a look. I want to look from 1700. It's a very short program, so let's look from, say, 1720. And we can see from the monitor there is our line of text to type out, and then the stop command at 1708, or yeah, 170F is the 53, that's the S. 1710 is the colon, and our last 0, which we will need, is at 1711. So we would just simply save this to our disk. Save hello, comma 8 on our disk drive, or 1 if you want to use a tape drive, from 1700 to 1711. That's all there is to it. A full package with Tiny Pilot and like 16 demonstration programs, as well as a version of Pilot that has an extended match statement. So the match statement will do all kinds of things that you want to do when you're, say, writing an adventure game, or you've got a dialogue going on with a user. Think the Eliza program that we took a look at. Anyway, all that stuff is available on my website. And the link to that is in the description below. It's also available on Plus4 World. Plus4 World, aptly named because anything to do with the Plus4 of the Commodore 16 is on that website. Go visit them. Great people over there. All right, that's it for the video. Thanks for hanging out with me, and I will see you guys all later. Like and subscribe if it suits you. I'd appreciate it. Take care now.